Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll sketch this graph using the concepts of derivatives. So as per the problem, sketch a graph of a function f that is differentiable and that satisfies the following conditions. So prime of f at x is greater than 0 when x is less than -5, and prime of f at x is less than 0 when x is between -5 and 1 and when x is greater than 1. And prime of f at -5 is equal to 0 and prime of f at 1 is equal to 0 and f at -5 is equal to 6 and f at 1 is equal to 2. Now we are given that the function is differentiable, so that means that this function has no vertical asymptotes, jump, or any cusp points. So that's the first thing we need to understand and memorize about this concept. So now we'll start with this last condition, because the last condition gives the points that lie on this function, and these points will help us identify the direction in which the function is going on either side of these points. So the first point is given to us as -5, 6. And the other point is 1, 2. So we should start by plotting these 2 points. So -5, 6, so that's here. And then 1, 2, that's here. Now we should analyze the third condition. And the third condition is the prime of f at -5 is equal to 0 and prime of f at 1 is equal to 0. So that means that the derivative at these points is equal to 0, and that means the slope of the tangent at x equals -5 and x equals 1 is equal to 0, and that means the tangent is horizontal to the function at x equals -5 and x equals 1. So we can show that as horizontal lines at these points, and I can use broken lines to show that they are distinct from the graph we have to sketch. So the tangents at these 2 points are horizontal. Now we can continue our analysis with the first condition. So as per the first condition, so prime of f at x is greater than 0 when x is less than -5. That means the slope of the tangent is positive on the function to the left side of -5. That means to the left side of -5, the graph of the function is sloping upwards from left to right. So we can show that as a curve that goes like this. So as we go from left to right, you can see the function is increasing. Now as per the second condition, the prime of f at x is less than 0 between -5 and 1. So as you can see, to the left side of x equals -5, the function is increasing, but to the right side of -5, the function is decreasing because prime of f at x is less than 0. So that means the graph to the right side of -5 should be sloping downward all the way to x equals 1. Because if the derivative is less than 0, that means the slope of the tangent is negative. That means the tangent is sloping downward. So we can show that like this, and then the graph should continue sloping downward all the way to 1, x equals 1. Now as per the second condition, the prime of f at x is less than 0 even on the right side of 1 when x is greater than 1. So that means the function continues to go down because it should be a decreasing function. The slope of tangent to the function should be negative. So on the right side of function, we can show the graph continues to slope downward. So we can show it like this. So what we need to show is that x equals 1, the graph momentarily becomes horizontal, and that's why the tangent at that point is horizontal. So we can show it like this. I'm trying to show it the best possible way. So maybe like this. Yeah. So this can be the sketch of function f that satisfies these two conditions. So I'll just change a bit more. Just maybe more like this. Yeah. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand all the conditions very properly before we start sketching such a function. The easiest thing to do is to plot the points if they are given in the problem, and in this case they are given in the fourth condition. So that's why we started sketching this graph from the fourth condition, and then the third condition, which tells us the points where the tangent is horizontal. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.